Okay, my name is Jan, and today I'd like to talk about a topic I came up with presenting it yesterday for like a little company conference, and I decided I'll give it to you today as well. It's supposed to be a presentation for just 5 minutes. And because I'm a code quality freak, I wanted to talk about how to write better Ruby, and I picked a single topic, which is LSP. LSP, the Liskov substitution principle, is a software design principle. One of the many in this slide. Actually, this is the L in solid. It's a principle invented in 1987 in a keynote by Barbara Liskov entitled Data Abstractions and Hierarchy. We can consider this lady a pioneer in computer science. The principle is basically this. What does it mean? It's about inheritance and types. So, according to LSP, when we subclass or when we create a subtype of any type, the whole program should not really care whether it's using the base type or the subtype. And this has several implications on the method signatures that we use. So, what's the method signature? This is all the arguments the method receives. This is all the return values the method can return, and all the exception types it can raise. So it is actually very easy to violate this when we think about a dynamic language like Ruby. There is also an implication about the mutation of state that can happen from the subtype to the base type state. So basically, when we create a subclass and introduce a new type of state mutation, it's already a violation. This was all very theoretical, so let's look at how we can think of LSP in Ruby. Actually, we can't really implement it because it's more of like a language design principle rather than something that can be applied specifically to a dynamic untyped language like Ruby. Because in Ruby we have no type checker, we have no compiler, there are lots of runtime alterations that are possible. It's a dynamic language. So I'd rather ask, like, what can LSP teach us to write better and cleaner Ruby code? And yeah, in Ruby world, we are facing the big duck every day. If it looks like a duck and quacks like a duck, yes, it's a duck. So what does it mean? It means that inheritance, types, and polymorphism are basically implicit a lot of the times. And yeah, I'd like to show you a few examples about this and how we can easily violate LSP in Ruby so that we don't do it every day. So let's look at the first example of overloaded method, return type. Let's say we have a mini rainforest QA. By the way, that's the company I currently work for. It's a QA company that runs tests, and that's all we have to know for this example. There is a rainforest class, there is a test job class, and an automated job class. And it turns out the run method is accepting a job argument, but the job is actually, one of the job types is overriding the result method. So, well, we have to check whether the return value is actually what we expect based on the type that we pass into the run method. Another take on this in the same scenario would be when the method arguments are overloaded and they create a different signature. So let's say we have a different set of arguments for the result, in one of the subtypes in the automated job. And then we have to introduce additional branching in the run method. So think of how many ways we have in Ruby to pass arguments to a method. In fact, we have 7. There are 6 on this slide, but there is one more. And if you add all the complex types that we can use in Ruby, like hashes of arrays, nested hashes, etc., it's like it's very easy to actually mix them up when inheriting from different types and create inconsistent signatures. So the 2 examples were cases of simulated polymorphism, where well, it's a code smell, it's a violation of LSP, and when you see any of these in your code, it might be a symptom of that. The last example I'm going to show today is about exceptions. So, yeah, same scenario. This time we have a validation error in the test job, but the automated job calls out to some automation class module. The runtime is rescuing the validation error, but what happens in the automation? It raises another one, which is not a handled subclass of any of the errors in the base class. Like in the base, if we return to this example, yeah, we have a job validation error which is declared inside test job, and the violation of LSP here is that all the exceptions raised by subtypes should be also subtypes of parent class exception types, so that we can handle them neatly. Otherwise, the proper solution for that would be to wrap the automation error, the not automatable error, somewhere and wrap it in a subclass of some error coming from the base job class, so that it's handled altogether. Wrapping up, that was a crazy idea to present LSP in 5 minutes. Actually, it was 7 already. Why should we care about it? Well, following the substitution principle is guaranteeing us to have less branching in our code, and it also leads to cleaner error handling. It kind of fosters a single responsibility principle, because we have to think about how to structure the object hierarchies, and also fosters composition over inheritance, because actually, when we think about using STI in Rails, like most of the times, we just squeeze that data in the single table, but actually all the models do different things. And it's actually better to maybe try do it some other way. So how to care about LSP then? Well, I only had 2 suggestions really, because it's so abstract. It can't be enforced. Ruby is a dynamic language. We have to care about it ourselves. So yeah, code reviews is one way, and the other way is RUG. So RUG code smells are, well, simulated polymorphism is something RUG can catch. It also checks for nil checks, which might be a symptom of that as well. So yeah, use RUG. Thanks. That's it, and that's my name, my company, my GitHub. Give me stars. Thank you. Questions, pytania. Może być po polsku. Dzięki.